This video is going to give you instructions on how to use the spreadsheet to investigate optimizing surface area. In the instructions, part 1 says investigate. Watch this video, which is what you're watching now, to learn how to use a spreadsheet to investigate minimizing surface area for a milk container with a volume of 500 cubic centimeters and a height of 20 centimeters. What length of the rectangular prism gives you the least packaging? So we are investigating optimizing, and optimizing means the best. And in this case, best is the least amount of packaging because that saves money. So if we go to the part 1 tab on the bottom, you can see that I've started a table for you, and I'm going to show you how to use it. So you can see that it's got the numbers volume and height in there, and like the instruction said, we're going to work with a volume of 500 cubic centimeters and a height of 20 centimeters. So these are constants. So we could type in 500 every time, which is fine, but I want to show you some ways to use spreadsheets efficiently. That's one of the points of this video. And so what I'm going to do is this. I'm going to say equals, and you can kind of keep track of what you're doing in the formula bar up here. And whenever you push equals, it means that you're going to have some sort of equation or function. And in this case, I'm going to do equals, and I'm going to refer to this cell. So I'm going to say what happens in here, which is E6. I'm going to refer to C4, which is this highlighted cell here. Now, if I push enter, oops, I want to refer to that one, and I push enter, and you can see I get 500. Now, if I grab this little dot down here and I drag it down, that is called the pull handle, and what it does is it actually reproduces the formula that I made in the cells below. But when I did that now, because I was referring to cell C4, you can see in C4 here, row 4, column C, you can see that just below it is C5. So when I dragged this down, it thought I wanted to copy everything below it one by one. And you can even see if I click in this blank cell here, it did copy. I mean, it did put something in there. It put what was in C6, which is right over here. And you can see there was nothing, and so forth. This one thought it should be C7. But I don't want the row number to go down every time. I want this to be 500 every time. So what I can do is I can click and I can put what's called the constant symbol, which is the $sign. And if I put constant C, that means it will always be column C. And if I put constant or $4, it will always be row 4. So that comes up as 500 again, and you'll see what happens if I drag this down. It's going to stay at 500 every time. Now, the other thing we know about this problem is the height is always 20. I'm going to do the same thing. Constant E and constant 4. So that's going to refer to this 20 here. I'm going to push return, and I can bring this down. Now, the point of this work today is you're going to investigate and try and find the minimum surface area, the least amount of packaging. And if we're going to investigate, one thing we can do is we can think about one variable we're going to change systematically. In math class we talk about investigating systematically, so we're going to change one thing systematically. Now the height and the volume are going to stay the same. but the length is going to change in a systematic way. So I'm going to put 1 in there. Let's start with 1 centimeter in the length. Now, again, I could write in 2 and 3 and 4 and whatnot. Okay, but I'm not going to do that. Instead, I am going to use a formula. So if I go equals, I can refer to the cell above, and then I can do plus 1. And what that means is that it's just going to add 1 to the cell above. Now, I'm not going to put a constant symbol in front because I do want the row to go 1 down every time. So watch, I'm going to drag this pull handle down here, and it goes up by 1 every time. The length increases by 1. And you can see that in this cell B8, it took B7, which was the cell above it, and added 1. And then in B9, it took the cell above it, B8, and added 1. And it just keeps doing that every time, so that's nice. Now, to find the width, well, we know that for a rectangular prism, length times width times height equals volume. That's only true for rectangular prisms. For cylinders, that's not true because the base is a circle. But for rectangular prisms, the base is a rectangle, and so we can do that. But instead of like going to the side and getting a calculator and calculating the width that's needed to make this volume 500, we're going to use the spreadsheet. So I'm going to put equal, and what I'm going to do is I am going to refer to this cell here. So that's our volume, and I'm going to divide it by the length and the width. Length times the width. And that will give us, I'm going to divide it by the length times the height, and that will give us the width. So I'm going to refer to this cell by clicking in it, and then I'm going to push times, and I'm going to refer to this cell and clicking in it, and I'm going to put brackets. So that means 500 divided by length times height will give us width, because that's the missing or unknown dimension. So if I do that, well, let's check. Does that make sense? Does that work? 25 times 1 times 20, that sure does equal 500. You could check that by hand if you want. Now, all I have to do is grab this pull handle and drag down, and it will do the calculations for me. The width when the length is 2 is 12.5. When the length is 3 is 8.333. Now, when you do this, you may want to change the amount of decimal places that you see. So, because part of the work that you'll do in a later project is like, well, what degree of accuracy and is reasonable, and like how many decimal places do I need in order to be reasonable for the context of the problem I'm solving. So you can, if you highlight the cells that you want to adjust, you can go up to these buttons and you can either decrease or increase the amount of decimal places. And you got to be careful, because like if you put it at 0, you see that it could hide. It makes these look like they're all width of 2, but really they're not. It just gets rounded up. So I'm going to increase the decimal places maybe to 2 or 3 decimal places in this case. Just depends on the context of the problem. Now, we're going to use this part over here to find the surface area. So it says the area of the bottom and the top faces, centimeters squared. So in order to do that, I can go equals. And the bottom and the top, there's 2 faces. So I'm going to go 2 times. Now, I can think of the bottom as the area of the bottom as being the length times the width. So I'm going to go times. So that times, by the way, is Shift 8. That's where you get the star symbol. And then there's the width, and I push enter. And we see it's 50. I want to find the area of the back and front faces. So there's 2 of those. So I'm going to go equals 2 times. And the back and the front, let's say that it's the width times the height. Okay, and that would be, so the area of those faces together, 2 of them, is 1,000 square centimeters. And then finally, I want to do the left and the right faces. And let's say that's the length, 2 of them, 2 times the length times the height. Okay, and then I've got that. Now, finally, the surface area is the sum of all the faces together. So I can do equals, and I can do this plus this plus this. So it's the sum of the top and the bottom and the front and the back and the left and the right. And if I hit enter, I can see that the surface area is 1090 centimeters squared. Now, I am wondering, let's adjust the decimal places. If I do that, okay, it looks like that is exactly 10,090. But I suspect that because I have like these 0.333 over here, that not all of these will turn out to be exact whole numbers. Now, the nice thing is I can just highlight this, grab the handle, drag it down, and it does all the calculations for me. Now, remember, the instructions were what length of the rectangular prism gives you the least amount of packaging. So let's take a look. When the length is 1, then the surface area, the amount of packaging, is 1090 squared centimeters. And then when the length is 2, the surface area is 630, so it actually goes down. When the length is 3, it's 503, and you can see it goes down even more. And then at length of 4, it goes to 460. And then at length of 5, it goes down as well, 450. But oh wow, look at this. When the length is 6, it goes back up. And then when the length is 7, it goes up again, and the surface area, the amount of packaging material needed, keeps going back up. So if we're thinking about optimizing or minimizing the least amount of surface area, it looks like when the length is 5 and the width is 5 and the height is when the height is 20 and volume is 500, gives us the least surface area, the least amount of packaging. Now, formatting stuff, if you ever want to like make sure things are centered, you can highlight them and then you can like click on this thing, and then top and bottom, like if you put this up here, it moves everything to the top. I'll give you an example of that. I can move, you see how it moves everything to the top. You can move it to the center, etc. And you want your tables to look nice, because then I'm going to highlight this table and I'm going to do Command C, and then I'm going to go back to the optimizing surface area document, and I'm going to go Command V and I'm going to paste it. And you see it says paste table and it says link to spreadsheet, and we want that clicked, and I'll show you why. So it inserts the spreadsheet, and that's nice, but because we linked it, anything we change in the spreadsheet will change in this document, and I'll show you what I mean. So let's say I push escape, by the way, or click off of the table because I'd copied it. And now I'm going to click in this, and because this cell was referred to here, notice, remember, we didn't write 500 in here. We referred to this cell, C4, in here. And then also when we did our formula, we referred to this cell, which referred to this cell. So watch what happens. Let's say I want, instead of a volume of 500, let's say I'm thinking about a volume of 1,000 cubic centimeters. And you can see that all the calculations get changed. So it adjusted the width. Remember, the length was what we were investigating with. This is the thing we were changing. But because all the formulas were connected to this and this, everything else changed and adjusted. So we didn't even have to make a new table. So the width was recalculated because now we're dividing by, we're doing 1,000 divided by the length times the height. And then you'll notice also the surface area changed because all of the multiplication for the faces changed. Now watch this. What if we wanted a different height? I'm going to go back here and I'm going to keep this at 500, and you can see everything goes back. What if I want to investigate a volume of 500 again, but instead a height of 25? So same volume, different height. Okay, everything can change. So this was 25 before, right? And this changes to 25 here. Now let's go back here, and then you can see that there's this little link table options. You hit the refresh and update, and you can see that everything in the table changes. Okay, that should get you started. Enjoy.